Let's have a look at fraction size. What we want to do is compare fractions and try and work out which fraction is larger. So if we're looking at, say for example, 1/3 compared to 1/4, let's look at this visually. So I've got a rectangle here and I've split it up into twelfths. The reason I do that is because I want to compare 1/3 and 1/4, which I can convert both of those fractions into twelfths. Okay, so if we look at the green 1/3 here, if I shade in 1/3, you can see that these 4 twelfths here are shaded in green to represent 1/3. So in green here, those shaded boxes are 1/3 of the full quantity of that total rectangle there. And in brown, 1/4. So 1/4 of this rectangle has been shaded in, which is equivalent to 3 twelfths. So the reason I do that is because I want to have a look at how many twelfths each of those two original fractions equate to. So 1/4 is exactly the same as 3 twelfths by just looking at this diagram here. So there's 3 twelfths, which is 1/4, and 1/3 is the same as 4 twelfths. So when we convert these two fractions into twelfths, we can see that 1/3 is indeed the larger. So 1/3 is greater than 1/4. So the key here is to convert these fractions into equivalent fractions that have the same denominator. Let's look at the second example here. We've got 2/5 and 3/8. So I'm looking at my denominators and I want to draw a rectangle that is split up into 40ths. Okay, so I'm looking at 40ths. 5 times 8 is 40. So I want a visual display of a whole amount split up into 40ths. So that's what I've got here. In orange I've got 2/5 and I've shaded in 2/5 of this entire rectangle here. So by counting the smaller squares, which are equivalent to 40ths, I can see that 2/5 is equivalent to 16 40ths. Likewise with 3/8, so I've got 8ths going down here. Okay, the columns are 8ths, and I've shaded in 3/8, which is exactly the same as 15 40ths. So if you count these smaller squares here, remembering that each little square is 1/40ths, I end up with 15 40ths. So we can see here by comparing these two fractions, that is comparing 40ths, 3/8 is 15 40ths, whereas 2/5 is 16 40ths. So that implies, or that shows, that 2/5 is larger. So 2/5 is larger than 3/8, and that's because I've got 16 40ths here compared to 15 40ths there. Okay, last example. Again, looking at the denominators. Change these two fractions into 56ths. So visually, if I look at my rectangle here, each tiny little section is 1/56th. If I shade in 5/8, so the 8ths are the columns, so I've shaded in 5/8, and if we count up these smaller squares, which are 56ths, I end up with 35 56ths, and then 4/7, so the 7ths are going across in rows. If I shade in 4 of those, 4/7 gives me 28 56ths. So when I compare those two fractions, I can definitely see here by looking at the numerator, as long as the denominator is the same, that 5/8 is larger than 4/7. Okay, let's have a look at another example, but not draw a diagram. So I've got 2/9 and 1/4. Now what we've been doing is we've been multiplying the denominators to give us a different kind of fraction, but we want to compare denominators that are the same. So 9 times 4 is 36. So I'm going to change these two fractions into 36. So this one here, this fraction, 2/9, what I did was I multiplied that 9, the denominator, by 4, which means I also need to multiply this 2, the numerator, by 4 also. So 2/9 is the same as 8/36. 1/4, to convert that quarter or that 4 denominator there into 36, I need to multiply by 9, which means the top number I also need to multiply by 9. So 1 times 9 is 9, and once my denominators are the same, I can see that 9/36 is indeed greater than 8/36. So what we see here is that 1/4 is greater than 2/9. Okay, let's have a look at equivalent fractions now, which we have actually met in the previous few minutes of learning. So if we go back to this example here, 8/36 is equivalent to 2/9. Then 9/36 is equivalent to 1/4. If you look at some of these other examples, 5/8 is equivalent to 35/56. So that is equivalent fractions. So 3/8 and 15/40, are they equivalent fractions? Well, they are, and if we just look at how we get one fraction from the other, I can see here that to go from 3 to 15 in the numerator, I'm multiplying by 5, and I'm doing the same thing with the denominators. So that's how we can get equivalent fractions. Now these two fractions here, we need to find out, are those two fractions equivalent? Well, what do I have to do to go from 5 to 30 in the numerator? I can see I multiply that by 6. Do I do the same in the denominator? 7 times 6 is indeed 42. So these two fractions are equivalent. So if you're given a fraction, for example 3/7, and you need to find some equivalent fractions, all you need to do is multiply both the numerator and the denominator by any number. So I could multiply the numerator by 4 and multiply the denominator by 4, and I would get an equivalent fraction. I could multiply it by 10 and multiply that 7 in the denominator by 10, and I will also get another equivalent fraction. So that is how you can find equivalent fractions. If you were to go the other way to work out whether two fractions were equivalent, so 12/28 and 3/7, then you can either do the multiplying or we can do division. So 12 divided by what will give me 3. You can divide that by 4. 28 in the denominator, if I divide that by 4, will give me 7. So these two are indeed equivalent. Okay, moving on to simplifying fractions now. So simplifying fractions means that the goal in simplifying fractions is to find our simplest form of the fraction. And the way we do that is we want to find a number that divides evenly into both the numerator and the denominator. So if we look at 18/26, what number do we know of that divides evenly into both those two numbers? Well, the first number I see, of course, is 2. So if I divide both the numerator and the denominator by 2, I get 9/13. And just by looking at 9/13, I can see I can't simplify any further than that. So 9/13 is the most simplest fraction from 1826. Okay, 3/12. I can see here that both 3 and 12 are divisible by 3. So if I divide both the numerator and denominator by 3, I get 1/4, and that's as simple as you can break it down to. This last example here, the easiest thing to do is to halve. So I can see that both of these are divisible by 2, so you could just do that initially. So we get 12/36, and then you can see that both 12 and 36 are divisible by 12. So if I divide 12 by 12, then the denominator by 12, I end up with 1/3. So 1/3 is the most simplest fraction that you will get from 24/72.